All right, Aditya, this is Jake. I'm just going to run through a couple of things that you may not have been able to see on our screencast the other day, and bring up one or two points that I didn't even get to the other day, and how we can handle those. So this is the basic setup I have in Blender. I'm running 2.78. You'll notice that I've got GLSL setting instead of multi-texture right now. You pull down so we can see if you want to the coding. And then of course I've got the other window with the UV editor here, and we're ready to go. So I had said we were going to import in OBJ files, but actually we're probably either going to import in X3D or WRL. I think the ones that I have even are not WRL. I can do it in X3D. I've got lots of X3Ds, so we can do that. But for this one, I'll show you the WRL version. Okay, so I'm going to import in this. Notice we've got a name to it right here, citrate synthase. Import this into Blender. Now it's a little annoying, but it gives me like 3 light sources, and the molecule is way off center, and the origin point is way over here, but I don't know that any of that is important. I don't think it's important. So we'll just make this first to be smooth. Well, yeah. So we'll make this first to be smooth before we do anything else. And then you'll notice as well that if I hide this, I've got these small stick figures. I don't know exactly what to do with these yet. They have to be kept, and we have to be kept in relation to this object that we're looking at. You can't see this from the outside. Some of them you can. I guess you can with this one if you look into this small pocket. You can see that. It's important that this stay where it is in space in relation to the object itself. So I'm open to suggestions there to find out what we should do, but I'll go how I think might be best right now, and you can tell me if there's a better way to do it. I'll have another point about those a little bit later on. So we've got our object here. I'm just going to change the name. Oh, this is important as well. Is you'll notice that we've all of these cylinders that you see here, and then even when we get down into the spheres here, these are all the things that make up the these sticks right here, sticks and spheres. So be aware of that. And then the actual object that we have comes in as shape underscore indexed face set is how that appears. Okay, so we're going to, let's just go through. First thing that we're going to do is tab in, and we're going to W and delete all, remove doubles. And it should only take away about 10 in this version. If we import in the OBJ, it can take out 100,000 or more. It's pretty crazy. Okay, so now we've done that. We're going to duplicate the object. We've duplicated the object. We're going to either scale or decimate. It doesn't matter to me which order it is, so we'll just decimate first. And we're going to do the collapsed version of decimate, and we're going to do it down to 0.035 and apply that. Then before we unwrap it, we're going to scale this by 1.015. I'm just making it big enough so that it takes in some of the extra space of the details that it's missing as this gets decimated down. Okay, so now we're going to tab in and Smart UV project this. At 66 is fine. Now here's where you can see that we run into the problem that I'd said where All of this so far has been given up here in Blender, which is awesome, but this does not. So we want to create a new image and call it citrate synthase. This is the name of the object. 1024 pixels is fine. 1024 on height and width, that's great. Alpha is good, all that's good. Okay, now we've got our image. So now we can bake. So we select the high resolution. This is all stuff I'm sure you know. And then the low resolution together. We go over to the render panel, and we're going to bake this. We don't want full render, we want normals. And then we want select to active as well. And then we just want to bake that. This gives us our normal map here, which we need to save again in order for it to be useful. So we're gonna save image as, and it's gonna be citrate synthase.png. That's fine, it should give it the name of that we gave it previously. So save image as. That also, this does give us the code for that, which is great. But it doesn't give us, we would need in the Python code to say, or I guess the first time is really what we need for this to say citrate synthase, and then the second time just to repeat this as the object name, just the same name as what was used before. So you're gonna have to use a variable to be a placeholder for that. After we're done with that, we can tab out. Oops. We'll just select our high-end one. Now this actually already brings me to an area where we've got a little bit of a problem. Is we duplicated just this one object and then we scaled it up by 1.5%, right? 1.015. The problem is then that the underlying structures are now all, they're not going to be the correct size in relation to this. And so I should have tried to figure out what to do there. I haven't figured it out because I'm not sure how to handle that. So I would appreciate your help on that. We'll keep going and then we'll come back to that. Now that we've done this, we're just going to go over and we can, first of all, we can get rid of some of the stuff so we don't see it as much. Grab this and move it over. Now, once again, as I move this over, now we've lost the relationship of the underlying molecules. So we'll need to grab those and move them over as well as having sized them up correctly, but not having used them for the Smart UV project, okay? So for this object, it should already come in with, with the material. And now we're going to go to textures. We're going to add new texture. We're going to make sure that on the image sampling, we've got normal map selected. UV for the coordinates, flat, that's all good. We don't want color, we want normal for the geometry. And then the last thing I believe for us to do is to actually select the image citrate synthase, and that's by clicking this icon to the left. And now we've got citrate synthase there and normals, and this is not looking exactly as it should. That's why I had forgotten to put it into texture mode, of course. So now this is in texture mode. We'll see this image here as having the correct texture. Okay, so that's pretty much it of what we need to do there. Now, as I'd mentioned before, we need to be able to figure out what to do with the small molecules. Now, there's a few things I want to be able to do. First of all, I want to be able to scale them and duplicate them over and retain them with this object here. I don't want them to be a part of the same mesh though, but I want them to still be in that same area. I don't know how we do that. There may be one thing that we do is if we hide this and just go look in at our molecules. these molecules are actually have way too many vertices as well. And one thing that's nice about them is, let me just grab all of these here so we're focusing on them correctly. Okay, so one thing that you'll notice is that we only have a couple different colors. We've got this gray, we've got a blue, and we've got red. And then on the tips, these are actually spheres, and then you've got small cylinders. Now, these small cylinders, some of them are all the same size, right? You can see that even like the blue ones right here, the same size as this one. But then you've got a couple other sizes. You've got long cylinders, as you can see. And I believe we only have those two sizes. And I need to be able to decimate these down, but still have them look somewhat okay. My first thought was to replace these with cubes where they can be connected to the adjacent, maybe not cubes, but a rectangular three-dimensional figure where the vertices could be connected here. I don't know how best to do that. I'm wondering if one thing that we could do is we could bring in an object that's decimated down, that's just like this, and pair them together. So you've probably seen how you can do something like, we'll just grab this one right here and go in and add a modifier, and we'll decimate it, and we'll do subdivide. I think that's working. And now we're down to 16 vertices on that versus the normal ones that are 32 vertices on that. That didn't do it as much as I wanted to. But now that we're down to about half, one thing that we can do is if we hold shift and select the next one and do Control L, that's L as in Latin, then we do object data. What you see on this one is that this did not work. Okay, so if we then grab one of these other objects that hasn't been decimated down, and we hold shift and select this and do Control L, and we make a link with the object data, what we see now is that this one, while yes, they're connected, this one now is only going to have 16 vertices as well as this one only having 16 vertices. I don't know if there's a better way to do it than this, but maybe we could make something where it's recognizing the long and the short. It would also have to recognize the color, which would be a big pain in the butt too. The spheres are another thing that's a huge pain in the butt because we don't need 242 vertices for a sphere that's super small. In fact, what I would prefer is that we just delete the spheres, and then on these objects here with an Alt right click, we just close that off as a face, and that would be good enough for me on those. That would save us 242 vertices for every single one of those spheres, right? So I don't know how that would be best to code that in. Maybe we don't worry about that for right now. Maybe the only thing that we worry about is the code in general. Not everything that I'm importing in is going to have these molecules attached to it. And so we may not need to worry about it right now. We can come up with a solution later on. I did want you to be aware of it in case it would change the way you approach the problem. I don't want you to have to redo your work later on because you didn't know that first we have to copy these over along with our molecules, and that we also have to keep everything in relation to one another where it is spatially. Okay, and I think that does it for everything that we needed to have done. We of course then just need to save this file as, you know, whatever the file name was, and then along with that saying decimated and baked normals is what I'd want this file to be saved as, and it can be just saved in the same place. And then as well, like I said, I'll have a list of 300 plus of these, and it would another part of the project that would be great is if you could just create that for loop you were talking about to just run through and do this with each of them. So I'll leave you to do the coding for this particular part, just so we can do a test run on a couple molecules and see if we can get it from A to Z. And then you can tell me what you think about this other problem of duplicating these over and bringing them over spatially, as well as possibly how we can get these down to a much smaller vertices count, because all of these ones right here are going to kill me in terms of the number of vertices they are when I'm getting all of my molecules and stuff put together. So yes, good luck on that. We can talk more. All right, thanks so much, Aditya.